Hey, welcome back to Algebra 2. Stand by a moment while I get the camera adjusted. For some reason, the picture that I see when I set this thing up is not what I see when I actually hit the record button. Okay, we're good to go, I do believe. All right, first, one little request of you. When you turn in assignments, I received about yay many emails in my inbox over the past 24 hours. And then I have to take them and sort them into folders, and it's a little bit of a pain in the neck. Please, I would ask that everybody use the same format for your subject line when you send me emails. Your subject line should say, in your case, either Algebra 2A or Algebra 2B. Please don't forget to designate whether it is A or B. I have two separate folders for the two classes. So Algebra 2, whatever, and then the page number, in this case, page 269. So please follow that convention for all future emails. You can, if it's a makeup assignment or something other like that, you can add in the word makeup or something so I'll know. Also, please try to minimize the number of unnecessary emails. I appreciate folks responding to an email by saying something like, thank you. Yeah, that's nice, but it adds one more email to the list of emails in my inbox that I've got to sort through and say, okay, is there anything really important in this one? And I've got to click it and say, nope, all they're doing is saying thank you. Then I've got to close that, then I've got to put it in the trash, and then I've got to move on. So when you have about 85 emails a day from students, streamlining becomes very important. I spent my entire morning from the time I arrived until about 12:30 just processing emails. So please minimize the unimportant emails and use this convention for your homework assignment subject lines. Okay, and I move on. Let's see. Yeah, one of the really nice things about doing this online is I don't have to worry about nonsense going on behind my back. And I really kind of grew tired of the chickens that were, being played with behind my back. So it's good to know that that cannot be an issue since we're all doing this online and you are not anywhere near. So no chickens, that's nice. We now move on though to page 269, number 2. Now, some of the papers I was looking at, and let me just be totally honest here, folks. I don't have time to grade every problem on every paper that is submitted. Sorry, I'm not that good. But I do some spot checking. I'll open up your file, I browse through it, I look for some key problems, make sure you're doing them correctly, and I move on. Sometimes I don't even have time to do that. I just look at it and say, is that the right assignment? Yep, that's it. Sometimes I slow down and look more carefully. It varies. But in some of the papers I saw, even on number 2, you were doing them not the way I taught you, not the way I want you to do them. You were doing them by other methods. Some of those other methods are good methods, but it defeats the purpose of the practice in this section. Let's use this as an example. 1/3 minus 5/6 equals 1/x. Yes, I know that you can easily change the 1/3 into 2/6 and then subtract 2/6 minus 5/6 is -3/6, which equals 1/x. And then if you think about it in a moment, this says the reciprocal of x is -3/6. So that means x must be -6/3. So x ends up being -6/3. Wait a minute, -6/3, better known as -2. Yes, that is correct. And there are other approaches I saw folks using. But what I wanted you to do for practice, to warm up exercise, I wanted you to do it this way. 1/3, right? Yes. 1/3, I got that right? Yes, okay. I wanted you to multiply both sides of the equation very carefully by the, let's hear it, LCD of all the denominators. Yes, the LCD of all the denominators. The LCD of a 3, a 6, and an x is 6x. You multiply by 6x on both sides. But that's more trouble. Yes, in this case, it's more trouble. But that's not going to always be the case. If we multiply 6x times 1 over 3, remember this is the same thing as 6x over 1. This is basic stuff from elementary school. If you had like 6 times 1/3, they taught you it's going to be 2. Okay, same thing here. The 6 over 3 becomes 2x times 1 is still 2x. Minus. Here the 6's cancel. If the 6's cancel, it leaves us with 5x. 5x equals. Here the x's cancel, leaving us with 6 times 1. And we're practically done. Subtract 5x, that's negative 3x is 6. Divide by negative 3, x is negative 2. We're done. It's over. We move on. No, I'm not going to do all of these for you because I just don't have that kind of time. Watch out. I did catch one person making some careless arithmetic mistakes on some of these. Be very, very careful. Number 4, your answer should have been 144. If you did not get 144, and some of you didn't, look more closely at what you did. Try to track down your careless mistakes. You multiply both sides by 12 very carefully. Number 6, let's put 6 up here. 6 says y plus 2. Let me make that more clear. Y plus 2 over 4 minus y minus 1 over 5 equals 15. All right. Now, some of you did some strange things. I could not understand what you were doing even. Some of you did some strange things and didn't show much work and got the right answer. Of course, that always raises questions in the mind of a teacher. Please show your steps. And the first thing I want to see on your paper, especially on the test, which is coming up soon, I want you to show me what you're doing to both sides to help me be assured that you're not getting your answers from some other source rather than your brain. So, what's the LCD of the denominators? LCD of a 4 and a 5 is 20. So we multiply both sides by 20. Again, with the utmost care, multiplying both sides by 20. Why? Because if I multiply by 20, cool things happen. Here, the 20 over 4 becomes, yes, I heard that, 5. So now we've got 5 times this thing. I could just do that in our heads here, but let me go ahead and write that out. It's going to be 5 times y plus 2. Minus, bring that down. And then what's 20 over 5? 20 over 5 being 4. So now we have 4 times y minus 1. That's 4 times y minus 1. There are some of you who jumped from here to here and didn't show me that you were multiplying by 20, which makes me start wondering, how did they get this? Did they get this online? Did they get this from a friend? Or did they actually multiply by 20? Please, folks, keep yourself above reproach. Make sure you eliminate any possible concern on my part. Show me what you're doing on this assignment and all future assignments. Show me what you're doing. Over here we have 2 times 15 is 30, so 20 times 15 is 300. And from there, we multiply this out. We get 5y plus 10. Now there was at least one person who did not have parentheses here, yet still ended up with the right answer. That raises red flags in my mind also. These parentheses are important. So we have here a minus 4 times y is minus 4y, but watch out. We also have a minus 4 times a minus 1, which becomes plus 4. Plus 4. Does that really matter? Of course it matters. Okay, now, here we've got 5y minus 4y. Well, that's going to be nice. That's just plain y. Cool. Here we got 10 plus 4 being 14. Then we simply subtract 14 from both sides. And y is, what, 2 86, and it's all over. Ta-da, done. That's the procedure I want you to follow. Okay, number 8. 888. And some joke about 8 eating. So what was that joke? Why was 8? I don't remember what the joke was. I'm terrible at jokes, but some joke about 8 eating something. Anyway, clearing that, going on to numbers, now I'm lost. Number 8, 4 over 3y minus 3 over y equals 10 over 3. All right, for this guy, LCD of a 3y, a y, and a 3 is 3y. So we multiply both sides of the equation by 3y and 3y. Over here, look at the marvelous thing that happens. The 3y's cancel. I'm left with just 4. Minus. Here, the y's cancel. If the y's cancel, I'm left with 3 times 3. 9. Cool. Equals, and here the 3's cancel. I'm left with 10y. 10y, and we're practically done. 4 minus 9, negative 5, equals 10y. Divide by 10, y equals, watch out, I see way too many people. I didn't notice it on this assignment, but I wouldn't be at all surprised if somebody did this. I see folks who have a knee-jerk reaction. Oh, I know, negative 5 times 2 is 10. It's negative 2. Wait just a moment. You're trying to tell me that 10 times negative 2 is negative 5? I guess not. No. You're not dividing 10 by negative 5. You are taking negative 5 and let's do it this way. We are taking the negative 5, we're dividing both sides by 10. The 10's cancel. Here I have negative 1/2, not negative 2. Now that does make sense because back here, what is 10 times negative 1/2? Ah, it works. How about that? By the way, as we go along from day to day, if you find that I make a mistake, normally if I mess up, somebody sitting out there says, Mr. Pierre, you messed up. And I say, oh, you're right, sorry about that. Okay, folks, if I mess up on these, I'm never going to know it unless you tell me by email, and then I can send out an email apologizing and say, oh, at minute number 562 on that first video, there's an error. I should have done, so just please let me know if you spot an error. But before you email me, please be absolutely certain that it's really an error and not just a misunderstanding on your part, because I don't want to start getting emails about errors that are not actually errors. Okay, and let's see, again, I really don't want to do all of these. Let's see if we can streamline things some here. Number 10, we're going to skip number 10. By the way, I think some folks did number 10 by cross-multiplying. That works, you can cross-multiply. But I really would have rather seen you multiply both sides by the LCD. What's the LCD? Well, here I go, doing it. I wasn't going to do it. Y minus 5 over y plus 1 equals 3 over 5. Okay, the LCD of a y plus 1 and a 5 is, get this, is it not simply 5 times y plus 1? Mm-hmm. Multiply by 5 times y plus 1. Mm-hmm. Here the y plus 1's cancel, leaving me with 5y minus 25. Here the 5's cancel, leaving me with 3 times y plus 1. Well, Mr. Pierre, that's exactly the same thing I had when I cross-multiplied. Yes, cross-multiplication does work, but I want you to practice using it by this method because there are many more problems where the cross-multiplication is not going to work for you. You need to get used to multiplying by the LCD. And then, of course, from there we subtract 3y from both sides, and then we add 25 to both sides, and then divide by 2, so y is 14. All right, and I said I wasn't going to do it. Okay, let's see, that was number 10. Number 12, the LCD for number 12, the thing you're multiplying both sides by. What is the LCD of a y plus 1 and a y minus 3? The LCD that you're going to multiply by is simply y minus 3 times y plus 1. Let's do this correctly. It's y plus 3 times y minus 1. Oh, wrong. Got the signs wrong. Y minus 3 times y plus 1. The LCD of these guys is just that. Y plus 1 times y minus 3. Multiply both sides by that. Here, these guys cancel. You're left with that times this. Here, these guys cancel. You're left with that times this. You go from there. I'm not going to do that one in detail because I can't do everything. Number 14. 14 is really more of the same story. The LCD you multiply both sides by would be 3y. Multiply both sides by 3y. Couldn't we just cross multiply? Yes, you could just cross multiply. Answer on 14. How about answer on 12 also? 12 turns out to be 11. 14 turned out to be 3. Number 16. Oh, that was nice and easy. The LCD of a y, and a y is y. You multiply both sides by y. All those y's on the left side disappear. You end up with 8y on the right side. Well, you could just about do this one in your head. But I'm not going to take time to try to do it in my head. I'm going to look at the book. 16, my book says you end up with 3/4. 3 over 4. Those of you who got 0.75, put away the calculators. Come on. 3/4. Number 18. The LCD for number 18 is going to be what? 6 doesn't work. 12 does. Yeah, 12. And don't forget the y. The LCD is 12y. You multiply both sides by 12y. And when you multiply both sides by 12y, wonderful things happen. Do I need to do this one? No. I'm going to do it really fast if I can, to save some time for those who'd really like to see it. 1/3 minus 5 over 4y. Hey, could someone read it to me, please, so I don't have to keep looking at the book? Okay, I'll read it to you. Thank you. Equals, okay, I got that part. 3/4. Thank you. Oh, make that look like a 3? Yeah. Okay, 3/4 minus, thank you, 1 over 6y. Thank you very much. That made things easier. I hope you read it to me correctly. Yes, I did. Okay. The LCD again is 12y. We're going to multiply everything by 12y. Multiply by 12y. Multiply by 12y. Over here, 12 divided by 3 is 4. Why are we dividing? Well, because this is 12 over 1. This is a 1 over 3, so we simply cancel the numerator and the denominator. This is 4y. Uh-oh, watch out. Haha, I almost didn't notice that. That's negative 4y. Here, we have our 12y over 4y. The y's cancel. The 12 over 4 becomes 3. 3 times 5 minus 15 equals, here, 12 over 4 becomes 3. So what am I left with? Oh, the 3's cancel. No, they don't. That 3 is in the numerator. 12 over 4 is 3. 3y times 3, 9y. And then here, the 12y and the 6y almost cancel. The y's are gone. 12 over 6 is 2. 2 times 1 is minus 2. Thank you. And then we will do what? Let's go ahead and add 4y to both sides. That's 13y. While we're at it, we'll add 2 to both sides. That's negative 15 plus 2 is negative 13. Oh, how convenient. They're being nice to us. Divide by 13, so y is negative 1. Meditate on that work for a few moments, or pause the video if you need to and stare at that for a while until you see exactly what happened here. Moving on. That's a nice thing about the video. You don't have to ask me to slow down. You just have to stop the video. Kind of cool. We're going to get to liking this. Number 20. How far did this assignment go, by the way? Mr. Bear, we're supposed to stop way back at number 6. No, we weren't. Liar. Okay, let's see. We are going all the way through to 26. Okay, right? Right. And where are we now? We're on number 20. Okay, I think I'm going to bypass the details on this one. What is the LCD for number 20? The LCD of a y and a y minus 2 and a y. The LCD would be y times y minus 2. No, the LCD is not y minus 2. It doesn't work that way. Consider this to be a factor. Remember the concept of factoring? This is a factor. Your LCD is y times y minus 2. That is what you would multiply both sides by. That is what you would multiply both sides by. Here the y's cancel. Here the y's cancel. Here the y minus 2's cancel. That's always nice. You go from there. What is your answer for number 20? Number 20, my book says it is negative 23. Negative 23. What? Yes, negative 23. Number 22. Now, what went wrong in number 22? My book says that that it has no solution. By the way, there are some of you whom, again, I question where you were getting your answers. Some of you just copied the problem and said, can't be done, or no solution. Why? Did you know that just because you looked at it? I don't think so. You need to show me some evidence. If you try that kind of trick on the test, no, you're going to have to show me the proof that there's no solution. You have to actually work it out. Don't give me that, oh, no solution stuff. No, not until you've worked it out. 2 over 5t equals 1 over 10t minus 3. Thank you. Minus 3. I already saw that. Okay. Here, your LCD of a 2t, a 5t, and a 10t is simply 10t. We multiply both sides by 10t. Multiply by 10t. I can never find the LCDs. Okay, here's the trick. You want to figure out what can I multiply both sides of the equation by. What one thing can I multiply both sides by that's going to make a 2t and a 5t and a 10t all go bye-bye. So what can I multiply by that's going to make a 2 and a 5 and a 10 all go away? How about 10? That's right. And what can I multiply to make a t, and a t all go away? A t? That's right. We multiply by 10t. Oh, you mean we multiply by 10t because it works? That's right, because it works. Over here, the t's cancel. 10 over 2 is 5. 5 times 1, 5. Minus. Here, 10t over 5t, the t's cancel. 10 over 5 becomes 2. Oh, 2. No. It's 2 times the old 2 that was already up there. Ah, yes. Okay, over here. Oh, nice. The 10t's cancel completely. We're left with 1 minus 3. Isn't that minus 3 times 10t? No. There's no denominator over here. It's just 10t times Mr. here. It is. Well, I'm not sure. Yeah, good thing I talked that through because I was about to make a silly mistake. Yeah, 3 times 10t is 30t. I don't know what I was thinking. All right, from there, what do we do? Oh, well, this is practically done already. 5 minus 4 is 1. 1 equals 1 minus 30t. Subtract 1 from both sides. So 0 equals negative 30t. Well, that's why there's no answer. No. There's nothing wrong with this. Many students are just terrified of zeros. There's nothing wrong with the 0 there. Well, but. No, just what do you do to get t by itself? Divide by negative 30. Yeah, but. No, just do it. Divide by negative 30. What's 0 divided by negative 30? Oh, isn't that just 0? Yes, it's just 0. Then what's the problem? Why did the internet say the answer? Why did I think that the answer was no solution? Because you go back to the original problem, and guess what? You put a 0 in for these t's, what happens? What's 2 times 0? 0. Guess what you're never ever allowed to have in a denominator? Well, how was I supposed to see that? Sorry, it's your job to check for what we call erroneous meaning error, solutions. erroneous solution is t equals 0. You got it by following all the rules, by doing everything correctly, but your final solution ends up being wrong, not because you messed up, but because it is an erroneous solution. It is a solution that does not actually work. We discount it. This has no solution. And you would not likely see that from the original equation. You must show me your work. Those of you who are not doing any work need to start doing some work, because on the test, assuming, oh, speaking of the test, let me pause right here for a moment and address the test issue. Hey, Mom, Dad, could you come in here a second? You need to hear this, please. Thank you. Oh, Dad's down in the basement. Well, okay, well, Mom, one of you, I don't have to have both of you, just one of you. Come and have a seat on the couch. Thank you. Welcome to the algebra class. I wanted you here so I can explain to you how the test is going to be done. I have the test for this class scheduled for Friday morning. The deal is, I will send the test by email to the parents only. I will not send it to the student's email address. I will only send it to the parent's address. Parent, your job then is to print out the test and then hand it to the student. But then I expect you, I beg you to proctor it. They need to take the test in your presence. In addition to that, please make absolutely certain that they do not have access to their cell phone, or your cell phone, or a smartwatch, or a laptop, or an iPad, or whatever else. Make sure that they're using nothing but their own brain and perhaps a calculator. That's okay, but nothing else, please. Because I want to make sure that to the best of our ability in these unusual circumstances, that everything is above board, everything is being done properly, yes, done properly. So please proctor the test. Once it's done, I want you to sign the test, indicating that you actually were there, and then scan it or photograph it and send it back to me by email. And that's all there is to that. That is how we'll be handling all the tests during whatever length of time that we are doing online. Yeah, what else can I say? And students, be sure that you're showing as much work as possible. And if I find that your work looks exactly like Khan Academy or Mathway or whatever else thing you found to use, then I'm going to have some serious questions for you. So make sure that you're doing the work, showing the steps, make sure your answers match up with your work, and yeah, let's see if we can make this online testing thing go well. Okay, thank you, parents. You are dismissed. No, you stay there. Parents, you can leave. Okay, now back to where we left off. Let's see, I don't know where we were. We did 18, we just, what's that one? That one was number 22. 24. 24 is kind of fun looking. 24 has a glitch to it, a weirdness to it. They're messing with you. By the way, the kind of messing with you that they're doing here in number 24 is the kind of messing with that I would probably not do to you on a test. It's just a little bit on the cruel side. But you should be good at it. We've seen this kind of thing before. You should be good at this by now. Here's the problem. We know that y minus 2 times y plus 2 is y squared minus 4. That's old stuff from chapter 5 or whatever. Old stuff. But that's not y squared minus 4. That's 4 minus y squared. If only that said y squared minus 4. But yes, as we have discussed in the past a number of times, you can flip this guy around a minus sign, but just like if you change 5 minus 2 into 2 minus 5, you're changing its, yes, you're changing its sign. from positive to negative. Same thing here. I can flip that thing around to a y squared minus 4, but that changes its sign. So I've got to make up for that by changing this sign. The plus becomes a minus when this becomes a y squared minus 4. So you can feel free to flip two things around a minus sign as long as you also change the sign here or here, but not both, not both. Okay, so from there, what do? In our head or on our paper, in your head's fine with this. In our head or on our paper, we change this into y plus 2 times y minus 2. From there, what's the LCD? It's just that, y plus 2 times y minus 2. So now, we multiply both sides by y plus 2 times y minus 2. We multiply by y plus 2 times y minus 2. And cool things happen. Here the y minus 2's cancel. Look at that, leaving us with just 3 times y plus 2. That's 3y plus 6. Minus, oh, look at this. The whole thing cancels, leaving us with nothing but 2y. And you thought this was going to be hard. Ha! Here, the y plus 2's cancel, leaving me with nothing but 5 times y minus 2. That's 5y minus 10. See? Nothing hard about it at all. A little bit tedious, maybe. A little bit tedious, but tedium does not equate with hard. No, this is not hard. Tedious, maybe. Hard, no. So here we have 3y minus 2y is just 1y. Let's go ahead and subtract 6 while we're thinking about it. If I subtract 6 right now, that becomes minus 16. And, oh, we've got a 5y sitting here. Let's see. Part of me says subtract 5y from both sides. The other part of me says let's subtract y and add 16. Oh, let's just be brave, and we'll just subtract 5y. Y minus 5y is negative 4y equals negative 16. Divide by negative 4, y is 4. We're done. But not quite, because we still have to look at number 26. Just confirming the answer on 24. Yep, it is 4. 26, oh, I'll tell you what, yeah, 26 is very, very, very similar to 20, oh, wait a minute, that wasn't, oh, hold on, 26 and 24. Yes, 26 is very similar to 24. The only thing, let me take just a moment to review with you how to factor that last denominator, x squared plus 2x minus 8. You factor that and wonderful things happen. Of course, you can get some hints as to what those denominators have to be by looking here and here. These guys are probably going to be your factors. I haven't looked closely, but I'm assuming they must be. But you do need to factor this. So quick factoring review, very quick factoring review. To get the x squared, of course, you need an x and an x. Because there's nothing in front of the x squared, because the coefficient of x squared is 1, that makes this the easy kind, where all you need is two things that multiply to give negative 8 and add to give